All right, ladies and gentlemen, we're going to get into problem number 8. As always, we write down our rules. Always write down our rules. So let's read the question, and then we'll read all the options. So in science class, Trevion and Mir were using a science probe attached to a laptop to measure the speed of a marble as it exits from a 7-foot-long ramp. To double check the speed, they measured a section of the floor that was 10.5 feet in length and used a stopwatch to mark the time each marble took to travel that distance. Trevion and Mir discovered that it took 2 seconds for a marble to travel 10.5 feet. They used the formula R equals d divided by t to determine their calculation, where distance d was measured in feet and time t was measured in seconds. What is the constant rate of change that the marble traveled in feet per second to the nearest hundredth? Okay, so now we have, so what was the constant rate of change that the marble traveled in feet per second to the nearest hundredth? So we have 5.25 feet per second, 6.84 feet per second, 17.24 feet per second, and 13.53 feet per second. So we just read the question, we read the problem, we underlined the question, we read all the options as well. So in this case, this person here, the process is strong. All right, and then the concept is weak. Okay, because the math is all right, but they don't understand what's being asked of them here. So the concept is weak. And also this answer here for D, that's not accurate. All right, that's not accurate. So let's label and annotate here, right? So if you look here, this is the distance formula, okay? So they did good. Okay, they did good by boxing this formula, this term here. So the distance formula, all right? So the distance formula, in this case, we're having rate. In this case, the rate is the constant rate of change. The constant rate of change in this case is R. Okay? So the rate equals the distance divided by time. Now, ladies and gentlemen, this is the beauty of math. This is what makes it so incredible. Now, with the rule strategy, which is a very powerful strategy, notice how this person here, yes, she did circle her numbers. She did that, but she did not label them. So she's circling the numbers. She's getting closer to the true definition of what this question is asking, but she does not understand what these numbers represent. Okay? The 10.5 feet, and she also underlined 7-foot-long ramp here. Do not let them confuse you by adding other numbers. We're trying to go, the distance is the distance that the marble goes after it goes off the ramp. So if there's a ramp here, right? There's a ramp here, and then, so if the ramp is here, and if this ramp is 7 feet, what the question is saying is that after the marble goes down the 7-foot ramp, it then goes off of the ramp. After going down a 7-foot ramp, it goes off the ramp, and then it travels 10.5 feet in a span of 2 seconds, okay? So this is what we're looking for the constant rate of change. The 10.5 here, this is the distance. This is the distance, and the distance represented by D, okay? The distance is D. Now, the time, ladies and gentlemen, is 2 seconds. This is the reason why I need you all to get into the habit of annotating what the numbers mean. This is the time. And so the rate is distance divided by time. I see addition here, so that her concept is weak. Then I see subtraction here. All right, this is 10.5. This is an issue because 10.5, ladies and gentlemen, minus 2.0, this is not right. It's actually 8.5, but it's not asking for subtraction. It's asking for division, okay? The rate is equal to the distance divided by time, all right? So her concept here is very weak. It's a very weak concept because she's doing 10.5, which is the distance in feet, minus 2.0, which is the time in seconds, okay? We can't just do that because, first of all, feet and seconds are two different units, okay? That's like saying subtracting 5 apples minus 2 oranges. The units are different. You can't subtract 2 oranges from 5 apples because they're different. So the rate is equal to distance divided by time. So the distance is 10.5, okay? So the distance, as I said here, is 10.5 feet. And we're going to divide that, ladies and gentlemen, we're going to divide 10.5 feet by 2.0 seconds. All right? So let's do that right here. 10.5 divided by 2.0. How many times does 2 go into 10? 2 goes into 10, ladies and gentlemen, 5 times. So now we'll subtract 10 out. It's going to give us 0. We bring down the 5. Keep our decimal value there. How many times does 2 go into 5? 2 goes into 5 2 times. Okay? So it's going to become a 4. All right? It's going to bring us a 1. Now, let's add a couple of zeros. Bring down to 0. How many times does 2 go into 10, ladies and gentlemen? 2 goes into 10 5 times. All right? 5 times. So this, ladies and gentlemen, is our answer. Okay? 5.25 feet per second. All right? This is the beauty of it all, is that it all ties in together when you know the formulas. All right? So I'm going to challenge you all to learn all of our formulas, or at least learn how to use them. So the answer in this case, ladies and gentlemen, is A. The answer is A. All right? So that's not accurate. The answer is A. All right? So let's go to problem number 9. Let's go to problem number 9. Okay, so in this case here, well, we'll pause for here and then we'll do number 9 on a separate video. All right? So hopefully you all understand how I solved this problem here. I'll post this and you all can look over it for reference. So the answer to this problem, ladies and gentlemen, is A, 5.25 feet per second. What you have to do is you have to do rate. The rate is equal to the distance divided by time. We figured out that the time is 2 seconds. We figured out that the distance is 10.5 feet. So it's going to be the rate is equal to 10.5 feet divided by 2 seconds. So 10.5 feet divided by 2.0 seconds. So when we did 10.5 divided by 2, we got 5.25. And our answer is A, 5.25 feet per second.